What if everything you thought you knew about ancient technology was wrong? Imagine structures so advanced, they defy modern understanding, built over the millennia ago. This video unearths the lost blueprints of Roman engineering, revealing secrets that could rewrite history. Ever walked through the ruins of Rome and felt a sense of awe? We see the Colosseum, the Pantheon, and we think we know the story of Roman genius. But what if I told you that the greatest marvels of Roman engineering are the ones everyone photographs? What if the most incredible structures are the ones we've forgotten, buried under centuries of earth, and lost in the pages of dusty man? Today, we're not just visiting ruins. We're on a quest to uncover the ghosts of Roman engineering, the lost marvels that reveal a civilization even more advanced than we ever imagined. Let's start with a mystery that baffled historians for centuries: Roman concrete. We all know it's durable, but how durable? Well, structures like the Pantheon's dome are still standing perfectly intact after nearly 2,000 years, without any steel reinforcement. Modern concrete, by contrast, starts to degrade in about 50 years. What was their secret? For the longest time, we thought the key was volcanic ash, called pozzolana, which the Romans mixed into their mortar. This was a brilliant innovation, creating a material that was incredibly strong and even capable of setting underwater. But recently, scientists discovered something even more astonishing. They analyzed samples from ancient Roman seawalls, structures that have been battered by waves for millennia, and they found these tiny, white mineral chunks they called lime clasts. For years, these were dismissed as sloppy mixing, but it turns out they were intentional. When tiny cracks form in the concrete, rainwater seeps in and reacts with these lime clasts. The reaction creates a new calcite solution that flows into the cracks and hardens, effectively healing the concrete from within. The Romans didn't just build structures, they built structures that could heal themselves. Think about that. We're only just now developing self-healing materials, and the Romans were masters of it 2,000 years ago. This wasn't just lost technology, it was a lost mindset of building for eternity. Now, let's move from materials to machines. We marvel at the aqueducts, those monumental channels that carried water for hundreds of miles. But how did they build them across treacherous mountains and deep valleys? We often picture legions of workers using simple tools, but the reality was far more sophisticated. Take the BarbegalMill in southern France. For a long time, it was just a strange series of terraces on a hillside. But when archaeologists finally excavated it, they found the remains of the largest known industrial complex of the ancient world. It was a massive water-powered flour mill, with a series of 16 water wheels cascading down the slope, each one turning a pair of millstones. This complex could produce enough flour to feed the entire city of Arles, about 12,000 people. It was a true factory, a testament to their understanding of hydraulics, gear ratios, and mass production. But even more impressive is how they got the water there. They built an aqueduct that branched into two, with one channel feeding the top of the mill and the other bypassing it to supply the town. This required incredibly precise surveying and engineering that we associate with the modern era. The BarbegalMill shows us that Roman engineering wasn't just about grand public monuments. It was also about industrial-scale power and efficiency, a concept we thought was born in the Industrial Revolution. But what about the projects that were so ambitious? They almost seem mythical. Pliny the Elder wrote about a project under Emperor Claudius to drain the Fucine Lake, the third largest lake in Italy, to create new, fertile farmland. This wasn't just a simple canal. They had to tunnel through a mountain. The tunnel, known as the Claudian Tunnels, was over 3.5 miles long, dug from both ends, simultaneously, with dozens of vertical shafts, sunk from the surface to speed up the work. The precision required to meet in the middle, deep inside a mountain, using only rudimentary tools and observation, is staggering. It was one of the greatest engineering feats of antiquity, employing 30,000 men for over a decade. And it worked. For a while. The lake was partially drained, but maintenance was difficult, and after the fall of the empire, the tunnel fell into disrepair and the lake returned. It was considered a failure for centuries, a story of imperial hubris. But the engineering itself was a triumph. The fact they could even conceive of, let alone execute, Such a project redefines our understanding of their capabilities. The tunnel was eventually cleared and expanded in the 19th century, finally draining the lake for good. But it was built on the forgotten foundations laid by Roman engineers. And then there are the marvels hidden in plain sight. Think about Roman roads. We know they were straight and durable, but we often overlook the most brilliant part of their design: the system. They didn't just build roads, they built a network. Over 50,000 miles of paved highway, complete with standardized mile markers, roadside inns, and repair stations. It was the internet of the ancient world, allowing for the unprecedented movement of troops, trade, and information. An official message could travel from Rome to London in about a week, a speed that wouldn't be surpassed in Europe until the invention of the railway. But de venere era los secrets. Archaeologists have discovered that many roads had sophisticated drainage systems, with deep foundations of layered sand and gravel, and a cambered surface to shed water. They weren't just paths, weather infrastructure. They even built temporary pontoon bridges, like the one Julius Caesar famously constructed across the Rhine River in just 10 days. He didn't just want to cross. He wanted to demonstrate that no natural barrier could stop Roman power. His detailed account of its construction is a masterclass in logistics and rapid engineering. These systems, designed for permanence and speed, were the backbone of the empire, a legacy of connectivity that shaped the map of modern Europe, from self-healing concrete to industrial watermills, from mountain-piercing tunnels to a continent-spanning information highway. The true genius of Roman engineering lies in these forgotten achievements. They show us a civilization that wasn't just building for the present, but for a future they believed would be eternal. They solved problems with a level of ingenuity and ambition that we are only now beginning to fully appreciate. These lost marvels are more than just historical curiosities. They are a challenge to our own assumptions about the past, and a powerful reminder that sometimes the greatest innovations are the ones waiting to be rediscovered. The next time you see a Roman ruin, look closer. Look beyond the broken columns and weathered stones. You might just catch a glimpse of the invisible engineering that held an empire together and whose echoes continue to shape our world today. Thank you so much for joining me on this journey into the past. If you found this as fascinating as I did, please hit that like button and subscribe for more deep dives into history's forgotten secrets. Let me know in the comments which lost Roman marvel you find most incredible. Until next time, stay curious.